Actually, a random forest is a large collection of decorrelated decision trees. It uses multiple decision trees to classify any given instance by using majority votes. In this tutorial, I will explain how to construct random forest by using a simple dataset. Our simple dataset contains total 9000 records, 8 features and 2 classes. Each row of the table represents a separate record. For example, first row of the table represents the first record and 9000th row of the table represents the 9000th record. Each column named as F1, F2, F3, F4, F5, F6, F7 and F8 represents the features, and column named as class represents the classes like class A, class B. We have taken total 2 classes for simplicity. Now, how to construct random forest by using this dataset? As we discussed earlier, that random forest contains a large collection of decision trees. So how to add those decision trees from a single table? Now, suppose we want to add total k decision tree to our random forest. Here k may be like 100 or 500 or anything. So how it is possible? For this, we use a concept of bagging or bootstrap aggregating. To understand the bagging, we will go through a very simple example. Suppose we have a set which contains total 4 numbers like 1, 2, 3 and 4, and we have given a task to select 3 subsets randomly with replacement from this set, and each subset contains 2 elements. So our first subset will be like suppose it is 1, 2. Here random selection with replacement means in the next selection we can again use 1 and 2. So our next subset contains 2 random numbers which may be 2, 3. Similarly, our next random subset may be like 1, 4. Now here we can see that some numbers show some repetitions. So this is the process of bagging or bootstrap aggregation. For a standard training dataset D of size n, here in our case n is 9000, bagging generally generates m new training sets. Here m is equal to k. Each of the training sets represented at di and size n dash. Here n dash is always smaller than n. By sampling from D uniformly with replacement. So now let us select the first sample. In traditional random forest method, we generally select 2/3 of the total number of records as n dash. So in this case 2/3 of the records will be 6000. So we will randomly select total 6000 records from this table. So this is a sample table which contains total 6000 records randomly selected from table 1. As we discussed here, we can again reuse these records in the next random selections. So we will replace it here. Now we will use this table to show how we can generate a decision tree by using this sample data set obtained by using bagging process. So our next step is the generation of decision tree. Actually, generation of decision tree again uses attribute bagging. Here in the first process we use the bagging process, randomly select the subset of records with replacement. Now here we will use attribute bagging, means we apply the bagging but with attribute, not with record. Here we discussed that features F1, F2, F3, F4, F5, we say it attributes also. So our step 2 will be, for each of the k-sample training set we apply attribute bagging. This is also known as random subspace creation, and learn the decision tree such that the variable from any new node is the best variable, that is having least misclassification error among the extracted random subspace. Now let us go through the example. In attribute bagging with random forest, we generally prefer root n of size of total count of features in attribute bagging. So our root n may be like root 8. So actually we have total 8 features. So this is equivalent to 3. So we will randomly select 3 features from this table. Our table 3 contains total 3 features, like first feature, fifth features and seventh features, and the corresponding class. So this is our first feature, fifth feature and seventh feature, and the class for the first record. Here the number of records are same, like total 6000 records. We just make sample selection of random selection of features with replacement. So this is our first sample set. Now we use this sample set and apply decision tree formation steps like information gain, or gain ratio, or gain index, to create the tree. Now there may be a question like, by using this random selection of features, how to control these random selections and get a single tree? Because here we have chance of selection of multiple such random features, means we can select F1, F2, F3, F2, F3, F4, F3, F3, F5, F7, F4, F6, F8. So there may be multiple such tables like table 3, and there will be multiple trees. But here we said we will construct only one tree for each such table. How this is possible? After applying the decision tree formation step, we will prepare a confusion matrix and check its misclassification rate. How we can check the misclassification error, or we can assure that we have selected the best combination of features for decision tree. For that, just go through the starting step. Here we already discussed we used only 2/3 of the records, so we have 1/3 records left for each of the sample table. Now we will use this 1/3 of the training sample and use this learn tree and prepare the confusion matrix. This is a sample example of confusion matrix. So this is represents total number of results, predicted as no, predicted as yes, predicted and actual no, actual yes. This is row wise total, means sum of this and this, and this is column wise total, sum of this and this. So Tn represents true negative, false negative, true positive, false positive. So according to the formula, misclassification rate represents how often the classification is wrong. So it is like false positive plus false negative divided by total. So in this case it is 0.2. Now how to fix? Select a single tree, best possible split, best possible tree from this table 2 is clear. So in general we will repeat the attribute bagging 10 times, means 10 times we select tables like table 3 and check the misclassification rate, and we select the table having minimum misclassification error. However, we can select more than 10 samples also, and such kind of attribute bagging is also very useful if we have a very huge number of features and compare to the total number of records. So by using this way we can get a best set of variable and decision tree for this sample table. So let us represent it as tree T1. Now we will repeat the process again. We will again select the random sample with replacement, and again we will get some table like that. We will use this table and randomly select the features by using this rule and check the misclassification error. We can repeat this random selection 10-20 times and identify the best suitable tree for each of the random samples obtained by using bagging or bootstrap aggregating. So by using this way we can learn total k trees Now we have a random forest with k trees. Now how to use this for classification? So for classification we use a simple process. For each of the decision tree, predict the class of instance and return the class which predicted most often. So for example, suppose we have, this is our extracted trees like trees T1, T2, T3 and Ti and then Tk. So suppose we have an instance I1. It contains a record with 8 features. We will test the corresponding features according to the feature used in the tree and get the class output. Suppose with tree T1 we get like class A. Tree 2 it says that no, class B. But we will check like that, and after that final classification we say that total count of class A is greater than class B. Then we can say that our record is related to class A. Now some more important points. The error rate of random forest algorithm. Actually, the error rate of random forest algorithm depends upon the correlation between any two trees. If suppose tree T1 and T2 are highly correlated, then error rate will be high. Means similarly, the strength of individual tree in the forest. What is the strength of individual tree in the forest? The strength of individual tree is obtained from misclassification rate. If all the trees extracted here shows a very little or low misclassification rate, then the random forest prediction will be highly accurate. Actually, there are some shortcomings also. Like random tree is not good in generalized case with new data. And second may be like if a variable is a categorical variable. In the case of categorical variable, with multiple labels, in that case random forest will biased towards the variable having multiple labels. Now we will explain a little bit more about attribute bagging or random space subspace creation. This is just a formal description of random subspace or attribute bagging. Due to the complexity of this entire expression, we try to explain it at the end of the tutorial. So let us however, I already explained practically how it works. So let each training object xi, where I is equal to 1 to n, in the training sample set, where total number of sample set is x1 to xn. Here x1 may represent the first record, x2 represents the second record, x9 represents the last record. be a p-dimensional vector. P-dimensional vectors means total number of features in the record. So this is a p-dimensional vector described like that: xi1, xi2, xip. In a random subspace sampling, one randomly select R very less than P features from p-dimensional data set X. One thus obtain R-dimensional random subspace of the original p-dimensional feature space. Therefore, the modified training set XB may be like that and consists of R-dimensional training objects xi is equal to xi1. This is equivalent to selection of 3 features randomly with replacement from the table 2. So here is this table 2 and this is table 3. Where R components are randomly selected from P components of the training vector xi, where B is greater than 1, means we generally repeat the process for multiple times. Here we use B is equal to 10 or 20 times. So this is a complete discussion of random forest.